Um, Good morning, good afternoon, everyone, depending on where you're sitting. Welcome to our Microgrid 101 Introduction Microgrid Design and Optimization. And my name is Michael Stadler. I'm the CTO and co-founder of Xendee. And today, my two colleagues, Rita and Lulu, will help you through this 4-hour training. And before we make a start here, I want to really go a little bit over the agenda so that you know what you can expect here. So we really set aside a couple of minutes at the beginning to introduce ourselves, but also maybe so that you can introduce yourself and that we can start an open communication here maybe. I will talk a little bit about the microgrids, what a microgrid actually is, the markets as we see them, and how they will evolve. I have a specific topic here around electric vehicle infrastructure because from our perspective, microgrids can really help here to mitigate some issues when it comes to utility limitations for these high power needs that we see for electric vehicles. The same is true for data centers, which are also now a new important topic, at least in the United States, and dealing with microgrids, but I will focus today on electric vehicles, talk a little bit about the challenges that we face while we design and optimize a microgrid. Then we will have a break, 15-minute break. And then I will talk about a couple of use cases which nicely demonstrate the benefits of microgrids. And after that, I will hand it over to Lulu, and she will give you an overview about the important input data that is needed for modeling this, starting with loads, tariffs, financing, incentives. She will also show you the whole platform, the Xendee platform, from the beginning to the end, so that you understand the workflow here. And after the last break, Rita will really do a full case with you. I believe it's an airport case here in California, which will involve PV batteries, and it's basically a microgrid case that we will design with you together. And then we hope that we can conclude this by noon Pacific time today. But before we go there, so maybe Lulu, Rita, you want to introduce yourself before I introduce myself here?
Yeah, definitely. So I'm Lulu. I'm the Director of Customer Success here at Xendee. Before joining Xendee, I used to work as a consultant at the Boston Consulting Group. And there I led different projects, but mainly focused on mining and oil and gas. And that's one of the main reasons why I decided to join Xendee, because I wanted to transition into green energy and create some positive impact in the world. I've joined Xendee 2.5 years ago, and ever since then, I've been working closely with customers, helping them model their microgrids and EV infrastructure.
Hey everyone, my name is Rita. I'm a customer success engineer with Xendee. So I joined Xendee about 1.5 years ago after transitioning from surface water and hydrology. At Xendee, I handle most of our technical support inquiries. So if you ever reach out to our support asking for troubleshooting help or understanding your data, I'm probably going to be the one helping you first. Nice to meet you all.
Thanks, Rita and Lulu. Yeah, I mean, as Rita said, Lulu and Rita, basically the persons who really do the work with you. I'm the CTO and co-founder of Xendee. I started in the research space. I was working for a long time at Lawrenceburg National Laboratory at the University of California up in Berkeley, in the San Francisco Bay Area. And also parts of the technology that we're using today in Xendee are going back to that time. And we started the research around this technology that we're using now for microgrid design and control more than 20 years ago. And I'm happy to having you here today. This Microgrid 101 is really the basics. We are also in the process of designing a more detailed course, which we might kick off within the next couple of months, which really focuses more on the specifics of the modeling. This course is really about for people who haven't really dealt with microgrids a lot, and we want to give them a little bit of a background about the markets, what microgrids are, and then Rita and Lulu will give you this intro in the Xendee modeling. But if you're interested in more detailed modeling, soon we will have more detailed training sessions and classes on that. So since this is 101 of microgrids, I was also thinking to really lay a little bit the ground what a microgrid is, because interestingly, if you go to the internet, you will find a lot of definitions with different nuances on microgrids. And I always go with a definition that we came up with more than 10 years ago at the Department of Energy, where microgrid is basically a cluster of controllable resources, meaning generation resources and also loads, which can be disconnected from the utility. And the key here is really, from our perspective, that it's close where you need the energy. Because if you avoid upgrading transmission lines, distribution lines, you're saving here money for the society. It's a cheaper solution in most cases. And it increases also the system efficiency. And on top of this, and this is how microgrids actually started 20 years ago, it was with combined heat and power units, because with CHP systems, you can use the waste heat for building heating, but also for cooling. And that's actually now a renewed interest for data centers that we are seeing, because with absorption chillers combined with cogeneration and or co-location of generation resources, we can reduce the electricity demand, because we're taking out electric cooling and use the waste heat for this. And that's what we're seeing in the work that we're doing with data centers. So it's really about the system efficiency increase. And if you have, let's say, the term smart grid, then this term smart grid, which is also used frequently, it doesn't imply any of these things. I mean, a smart grid is just smart because there's a communication between the resources, the generation resources, and maybe the loads. And you can do some demand response, but nothing in a smart grid says that you co-locate your generation resources where you have your demand. And that's, I think, a really big misunderstanding, because as you guys can hear, I'm from Europe originally and I have a German accent, but the Germans, I mean, and the Europeans are really strong on renewables, but they're not really getting, from my perspective, the microgrid concept, because they're building all these renewable centralized resources, which are basically large power plants, in the case of Germany in the north. And then you have the load pockets in the south, and you end up with upgrading the distribution lines and transmission lines. And suddenly everyone is talking about how expensive it is to implement renewable energy. And that's a big mistake, I think. And in the United States, I think we do this really, at least in the mix, differently, because we not only have these large wind farms or whatever it is, because we also have these microgrids, which really help, as we heard early on from someone, to reduce these investments in the transmission and distribution system. The challenge with this is, of course, in many countries, it's a regulated market, and the utilities make money by just showing that they need some investments in the distribution system. And this is why, for example, now in Europe, which is a deregulated market, the energy is actually the cheapest part of your bill, and 2/3 of your costs are actually now fees for supporting renewable energy and also upgrading the distribution system. So we see a steep increase in total system rates because of this challenge here, because it's not implemented as a microgrid where you have generation and demand closely located, and this is creating some of these issues. And I mean, as you guys probably all believe, microgrids are way better in this, because we can mitigate these problems with this. I mean, of course, most of you know what the benefits are from implementing microgrids. I mean, I already talked about this efficiency, the cost effectiveness. I mean, I mean, we have already grid defection in some parts of the United States, because microgrids provide energy way cheaper than utility energy. And I'm sitting here in San Diego, California, and I end up with 90 cents per kilowatt hour of on-peak rates. And if you combine this with demand charges, I mean, it's no surprise that even residential buildings, all of them installing basically batteries and PV systems to get rid of these high costs, right? Resilience, of course, is a big part of this microgrid topic. I mean, Puerto Rico, right? I mean, we're building microgrids for shelters and provide energy in emergency situations or for earthquakes. And the other thing is the sustainability. I strongly believe that with a microgrid, we can achieve a way higher renewable penetration than doing this in a centralized fashion, because I'm running my own microgrid, and I have an example about this. I mean, I'm a good citizen to the utility because most of the time I have a flat line against the utility, and I'm not really getting power from the utility. I'm not delivering it back because it's managed in a different way. But of course, this takes away some revenue streams from the utilities, and that's probably also the main reason why utilities, some of the utilities don't like microgrids. But with a microgrid, you really can offer services, as you all know, probably the utilities system can be part of ancillary service markets and so on, and that's actually a huge benefit. And the other thing, since we had this blackout in Spain just last week, and people asked me about this, and I also strongly believe that with a microgrid we have a more secure system because it's a segmented system, and we have way smaller cells than we see currently in most of the systems. And a lot of people believe that microgrids can be easily hacked or they constitute a problem, but at the same time, since it's such a small segmentation, it's also way safer, and you can really contain problems in the system, and it's not becoming as big as it was in New York 25 years ago, I think, or 20 years, not 25 years ago, most recently in Spain. So just a couple of weeks ago, I was interviewed by a magazine which does mostly work for utilities, and they actually were thinking that microgrids are a niche market, but the reality is that we're in an exponential growth for microgrids. And I mean, just this diagram, it shows it. I mean, we will have probably 170 billion market by 2032. And that's significant. And now with the data centers, it will even be more, I think, because I think there's no chance that we can provide 1 gigawatt so we can serve 1 gigawatt loads for data centers, which we are seeing through the public utility system, because I mean it takes 7 to 10 years in the United States to upgrade those systems, right? And this is why everyone is now looking at microgrids also when it comes to data centers. But the growth for this microgrids is different in different regions, right? I mean, in Europe, if we see microgrids, it's really driven by renewable energy. And in the United States, it's probably mostly costs and resiliency against outages. I mean, all these microgrids really live by managing costs against the utility. And this is what I have on this slide here. I mean, North America, it's really resiliency. We had some policies to support microgrids. They're still around. We'll see how long they will be around. But in Europe, if we see microgrids, it's really about the integration of renewable energy. And I'm not sure if you heard about this, but there's this concept of energy community. So in the United States, most of the time have energy as a service. So we build microgrids to provide a service to a community or whatever it is. In Europe, they came up with this idea that you basically have residential buildings, you have commercial buildings, they're all next to each other, and they're connected through the public distribution system. And they introduced laws so that the utility has to provide the public distribution system at reduced cost so that you can do energy sharing over the public system. And this enables better integration of renewables, because if someone has too much PV, they don't have to sell it back to the utility at a low price. They can share it internally with this community, and maybe someone else has a larger battery than needed, or maybe there's some hydrogen involved. And this way you get an energy community which can exchange energy within this area by using this public distribution system at reduced costs. So that's also, I think, a good idea to foster the renewable energy adoption here. In Asia, we know it's mostly about electrification. I mean, as we already said today, there's Fiji, and most of those communities either don't have electricity at all, or they're running on diesel. And this is where we can help with more renewable-based approaches. But in terms of market, not surprisingly, North America is the largest market for microgrids, followed by Europe and I suspect it's because people mix up terms here, and if they have a virtual power plant, they call it microgrid. So, I mean, based on my work or our work, I think this 28% might be a little bit too much. But nonetheless, North America, biggest market, followed by Asia Pacific with this electrification goals that we're having there. So on this left pie chart here, we basically see that 2/3 of all the microgrids that are in the market worldwide are basically grid connected. And 1/3, a little bit more than 1/3, is really for off-grid connections. I mean, this is Africa, Asia Pacific, also Alaska, where we really just have to want to provide basic service needs, right? But this 2/3 is really important because, I mean, we make money by managing the cost against the utility. So in terms of generation resources, this is really interesting because still the vast majority of technologies used in a microgrid are somehow engines which run on natural gas or diesel. I mean, 30% of all generation resources in microgrid are just still diesel. 24 is natural gas engines, then 21, which is CHP. So basically, what is it? 36, 30, 50, more than 75% is basically somehow a form of generator. And then only 15% is solar with some form of battery. So, and the reason for this is because microgrids historically were built based on CHP systems because of their system efficiency. And this is why the biggest market is actually university campuses and educational institutions, because large universities have a heating need, a cooling need, and an large electricity need. And this is why they always install some form of steam turbine, gas turbine, which is basically a microgrid. And these are the biggest markets still housing microgrids. And I have an example about such a microgrid here in California, San Diego, which is a 50 megawatt facility, right? So a very large microgrids. Of course, then remote microgrids, 25%. Military is growing. A lot of work is done in the military, and actually they funded a lot of research. Then we have distribution, which means some microgrids supporting the distribution system. And I know about a couple of projects which have been done by California utilities, basically building feeder-based microgrids to stabilize the system. And communities are at 9%, but I think they will grow a lot because, I mean, I know about plans here in San Diego to basically build San Diego, so to deliver energy to the city of San Diego through multiple microgrids. So that will grow probably. So a couple of years ago, we realized that electric vehicles really need microgrids to really, I mean, so that we can supply, I mean, deliver the goals that people have with all this fast charging. And I mean, it's nothing new. I mean, if we're talking about really fast charging the 250 kilowatt range or 125 kilowatt range, I mean, the distribution system is not able to handle this in most places. And I mean, as I said earlier, it takes 7 to 10 years to upgrade the aging infrastructure in the United States. And we even don't have the knowledge in some places to do that because, I mean, we basically never, I mean, the investments in the system were basically stalling for a long time. And now we have this interest in electric vehicles, and most recently, actually, the data centers, which creates a lot of demand for the distribution system. And this is why microgrids will be the solution for this, at least in a lot of these cases. But as we did this around electric vehicles, we wanted to actually get also the opinion from the industry here. And we ran twice a survey with roughly 200 individuals, companies in the EV space, meaning involved in EV projects, utility sector, or in microgrids. And the interesting thing was really that I think it was 70% came back and said, well, the biggest limitation actually for building this electric vehicle chargers is the grid itself, the permitting and the readiness of the utility system. The other thing that we found here is that, of course, a lot of these projects rely on incentives. I mean, 75% rely on the Inflation Reduction Act, for example, which I don't know where we stand at the moment at this, but it might go away. Maybe it's not going away. But more than 60% of the designers and developers of EV projects need to recover their cost through those incentives. I mean, which is a big number. And I think this also explains why there was so much uncertainty starting this year. And as someone said earlier, I mean, maybe people just realize now it's not going to be better, and we have to do these projects anyway because we see some renewed interest here. But a lot of people depend on incentives. So in more detail here about the grid limitations, we actually asked those participants about what they think about grid limitations. And the blue bars, basically the dark blue and the lighter blue, number 5 and 4, basically indicate that 70% said, well, I mean, the biggest roadblock is actually the utility itself. And of course, this also means that most people think that microgrids are a solution to this problem, as we will see on the next slides. And I speed this a little bit up so that I can be on time here. And this is basically as we asked them about the solutions. And we had multiple questions, and they were two-faced. So we said, well, what they think is most important, and then we asked them what they're currently integrating. So the top is microgrids. 84% in that industry thinks that microgrids will solve that problem. 60% already working on microgrids, so there's still more appetite for doing this microgrid projects. Because only 60% are doing it and 84% believe they should be done. So we will probably see more of these projects. The same is true if we said, well, what do you think just about PV and batteries? Again, 69% say, well, very important, 57% already doing it. Still, it will grow, I think, because the appetite is really big. The interesting part comes then when you think about individual technologies. For example, batteries. Only 35% think that batteries are important, but 39% have to do something at the moment to be able to install the projects, which is an indicator that the utility has a problem. So they say, well, I'm not sure if a battery alone is a good solution. Only 1/3 thinks it, but almost 40% are doing it something with a battery because they have to do something. Otherwise, they cannot implement the project. The same is actually even more important for gas generators. And we notice from our clients that we work with some of the largest clients in that space, that they actually dislike the idea of installing natural gas generators or diesel to charge the electric fleet, trucks. But they have to do it because there's no way around this. And this is why 30% of them installing these generators, but only 22 think that they should do this, right? And of course, it's becoming even a bigger problem with PV because you cannot control PV. So not many think that PV alone is a solution, but 35 doing something to at least get the cost somehow down. But if you add all this up, it's clear that the microgrid, this controllable cluster of resources of multiple technologies, is actually the best solution to overcome these limitations in the EV infrastructure space. The funny thing about this is we are also going to conferences, and I think for now we're actually giving up to going to conferences in the EV space because everyone is talking about individual charger protocols, and everyone knows that there's a problem with the energy. But interestingly, I think most people still think that the utility will save them, at least at the conference that I have seen. And they're in a waiting pattern here, holding pattern. And I mean, when I would talk to these people, I tell them, guys, I mean, don't be surprised if the utility is not coming through. And it seems like that people who are already working this space got the idea that it's microgrid. But I think there's still a lot of work that needs to be done to convince the industry that I think the utility will not be able to do this, especially in combination with the data center demand that might come our way here, because it will completely blow up the system if it is going to happen with all these demands.